Yes, I can hear you.
Yeah, good evening.
Good evening. Good evening.
Okay. Okay, so you already sent me your study area, mainly your boundary shape file, who is boundary 128. Okay.
Yes, yes,
And
yes.
I'll already develop the code for that, your water quality monitoring. So mainly total suspended solid, turbidity, and chlorophyll. How we can easily use
Yes,
the satellite image and get this type of information from here. Okay.
yes, yes.
So okay, so basically, I in this time I will show you all of those things one by one for my side, which I
Mm-hmm.
completed, and then try
Mm.
to implement such as when you want to work for that, suppose accuracy assessment. Then you also need to know about that ground truth data. Okay,
Yes,
so
yes, yes.
for that you already created the ground truth data also for
Mm.
that. So in this time we are
Mm.
just calculated the root mean square error RMSE.
Mm-hmm.
This we can calculate
Yes.
it and find out the accuracy about that. Okay.
Yeah.
Okay. So
And
yeah.
before we proceed, I wanted to know how you do treat the ground truth data because it is from five sampling points, and it is also from three different scenes. So I wanted to know like how you are going to treat it. Are you going to like to make a mean of the sampling stations as well as the mean of the uh, of the scenes?
Okay. Okay. So in this time, suppose in this time when you want to work for the root mean square error, we have to read the two value. One is that actual value, another is the predicted value. Okay. So actual value mainly we can get the actual value from the ground,
Mhm,
and
mhm, mhm,
predicted
mhm.
value in this time we put input as a satellite imagery, which I can get from the satellite images for that, and
Yes,
then
yes, yes,
from
yes.
that we can just simply apply the RMSE, then calculate
Mm,
the accuracy about that. So in this time you have the
mhm.
geolocation data for the specific point, is it?
Yes, 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 yes.
Okay,
Yes.
then we can easily suppose in this time we are also just check about the same geolocation on my satellite images.
Mhm.
What is the
Yes.
condition about the total suspended solid or chlorophyll or turbidity? Then we are just get the two value. One is the actual value which I can get from the ground, and another is the
Mm.
predicted value which I can get from the satellite images for the TSS, total
Yes.
suspended solid turbidity. Then we can easily make the
Yeah.
RMSE. There is no problem.
Okay. Okay.
Okay.
Okay.
Okay. So let me share my screen. Then I will show you that. Okay. And it also better. Suppose you want to take the suppose ground truth data at specific time. So in this time, we are
Mm-hmm.
also input the same images for the same time period. Then we can get the better
Mm.
accuracy. Suppose you want to take the ground truth data for the 15 January. So in this time, we are also put
Mm-hmm.
here the 15 January satellite image also. And then we can
Okay.
easily
Okay.
get the better accuracy about that. Okay.
All right. All right. Okay. I
So
get it.
let's go. Okay. So now can you see my screen?
Yes. 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 Yes.
So this is your area of interest. Yeah. So I already imported and then calculated three parameter. One is the
Mm-hmm.
chlorophyll, total suspended solid,
Mm-hmm.
turbidity.
Yeah.
Okay,
Yes. Yes. Yes.
and we are use this satellite images. So mainly this is the Sentinel-2 satellite imagery.
Okay. Okay.
It's loaded this. So this is the NDCI.
Okay.
First you show the satellite image. So in this time it look like that. Simply I set the band combinations such as suppose red, green, and blue band, RGB color,
Mm.
98% is increase. So now we can get this my study area,
Yeah.
Sentinel-2 satellite imagery. Okay. So this is my Sentinel-2 satellite imagery. So in this time, I just
Mm-hmm.
simply add the other layer. Suppose you can see this is the NDTI, mainly turbidity
Mm-hmm.
index.
Yeah.
We can calculate the turbidity study area, as well as
Yeah.
also we can see the result for the total suspended solid,
Mm-hmm.
the total suspended solid,
Yeah.
and finally NDCI, it is the chlorophyll about that.
Yeah.
Okay. Not only for that, suppose in this time you already have the geolocation data So how we can easily get the value? Suppose in this time you can click on the inspector tab. Suppose I just simply click on here. Simply click on here. So now I can get a specific coordinate. For this coordinate, what is the value about that? All of those things I can get from here. You can see NDTI, TSS. Yeah, so here you can see NDTI, TSS value, and chlorophyll index value. Okay, so in this time we can suppose we are just use the same geolocation which you want to use for your collecting the ground truth sample and make the chlorophyll or turbidity or total suspended solid. Just you are the same geolocation data. So basically it's just a predicted, okay, and actual value we can collect from the ground. So then we can simply compare and calculate the root mean square error and then calculate the accuracy from here. What the accuracy you can get from here. Okay, so it's another process. So for that, so basically this is the result now for your for your region of interest. What is the condition about that NDCI, total suspended solid, and turbidity? Okay, so now from here we can easily extract the your geolocation. Suppose in this time you can, it's also better if you want to send me Excel file or CSV file. Suppose in the Excel file or CSV file, if you include all of those latitude and longitude and also add the value. Suppose TSS value, also turbidity value or NDCI value, you can simply add one by one as a column. Okay, it's latitude, longitude, and column. Then we are also easily imported the CSV file in Google Earth Engine platform. Here you can see from asset tab we can simply import it to the also geolocation CSV file. Okay, so then we are just use the same training point as a and also extract the predicted value from this turbidity, chlorophyll, or total suspended solid, say for the same location. Okay, so it's a predicted value, and we have already the ground truth value. Then we can easily make the root mean square error and then find out the accuracy about that. Not only for that, in this code I also add here. Then another thing is that for the time series chart. So basically from this time series chart we are also get suppose click on here. So in this time, okay, so it's a breaking lines chart. In this time it show that. So in this time, this breaking line means that in this time there is the no turbidity about for this time. So this is so it shows like this type of breaking line. You can see it this time. Also you can get the chart in here. Okay, 8 May, 7 June. Okay. So in this time we are also use this type of geolocation, and we are also download the data is a Excel file, and basically we can get the time period. Suppose Sentinel-2. Suppose it will be available from 2015. Yeah, 2015 to present time. We can easily get for this location. We can easily get this any types of total suspended solid, chlorophyll, or turbidity. We can easily extract the information from here, and then also validate it using our ground truth data. So in this time, you also try to make the CSV file. In this CSV file, you just added the latitude, longitude, and also add the value, your ground truth value. Okay.
Yes.
Then we can easily import
the ground truth value for each of those parameters, right?
Yeah.
Okay.
Total suspended solid, turbidity, and chlorophyll. Just simply add that, and then we also import this file in Google Earth Engine platform and extract the information. Extract the information from the satellite images. Okay. Then check about the root mean square.
Because I already added them like. The second link that I sent you in the email, it included the location as well as the values for each parameter, and also the dates for the co-located images.
Okay. So kindly resend me again. Then I can easily find out that link. So